So let us start with the next problem of penetration. This time it will be a cylinder which is penetrated by, say, a square prism. Problem statement goes like this: a cylinder of diameter 70 millimeters. So cylinder of diameter 70 millimeters is resting on its base in HP. Is resting on its base in HP. It is completely penetrated by. It is completely penetrated by a square prism. A square prism having side 40 millimeters, having side 40 millimeters and axis parallel to HP and VP, and axis parallel to HP and VP, such that the rectangular faces of the prism, the rectangular face of the square prism is making 30 degrees with HP, is making 30 degrees with HP. The distance between the axis of the cylinder, the distance between the axis of the cylinder and axis of square prism is 10 millimeters, such that the axis of square prism, is in front of the axis of the cylinder, is in front of the axis of the cylinder. Draw three views showing the curves of penetration, of the object remaining after the penetration, It means that the square prism has been removed after penetration, leaving some square hole inside that cylindrical portion. Now as we start with the solution, we will start with the top view, which will be a circle, and as usual we will proceed to draw the side view by taking a line perpendicular to XY, and the intersection of that line with XY will work as the center for performing the rotation. Again, the circle is to be first of all divided into 12 parts, because those 12 generators will play very important role. So we have drawn circle of radius 35, and now this particular circle is to be divided into 12 parts, and we will be making use of the set square only, 30-60 set square, so that we can mark the 12 parts using the set square. That will be faster. So just mark the points. It will be easier as well as faster. Use of compass I am trying to eliminate to improve on the speed. and so we get the 12 parts of that circle. Now all these 12 parts should be taken to the side view. So we will have to draw lines parallel to XY through these 12 points. And also the 12 generators should be shown on the front view. This will work as the construction only. So we are required to draw 12 generators in the front view, and even in the side view those 12 generators should be visible, should be drawn. And so I had taken those 12 generators till the vertical line, and then using the intersection point of that vertical line with XY as the center, we will be rotating each of these lines up to the XY line itself. All the lines are to be rotated. So line number 1, 2, third line, then the axis, then the points which are below it, so all the points I am taking to the side view. And then we will be completing even the side view, and then we will be completing even the side view, that is by drawing all those generators perpendicular to XY. We have not yet done any naming to any of these 12 points, which we will be doing at the later stage. So we complete the side view part, and then we know that the square is to be drawn in the side view. Distance between the axis of cylinder and axis of square is given to us as 10 millimeters. So this is going to be the position for the square hole that we are going to draw. But that square is making 30 degrees, the face of that particular square hole is making 30 degrees with HP, so we will have to construct it accordingly. No need this time to construct it separately. We will draw one line making 30 degrees with HP, and then using that as the reference we can proceed with drawing the square. So a line drafter to that 30 degrees lines. Side of the square is 20, so you can measure 20 on each side, and then through those 2 points draw perpendiculars. And again on each one of them, from each one of them measure 20 millimeters on either side, giving us the square in the side view, which can be darkened also. So we get the square in the side view, whose one face is making 30 degrees with HP. The distance between the axis of the cylinder and axis of the square prism or square hole is given to us as 10 millimeters, and it is in front of the axis of cylinder. So the inside view, everything is shown, so I can darken the side view. And now these 4 points of the square are to be taken to the top view. So we will have to draw projectors through each one of them, each of the corner. Here I find that the corner is just next to one of the generators and one corner is outside the end generator of the cylinder. So from side view to the top view there will be a rotation now. So it's a rotation from side view to the top view of all the 4 points of that square hole or square prism. They are to be taken from side view to the top view. And then in top view you are required to draw those generators parallel to XY. So you get those generators in the top view, and in the same manner you will be having those generators even in the front view. This time none of them is overlapping any other generator, and so all the 4 will be seen distinctly. Now is the time that we should be naming the points. So for circle it is named as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Obviously in the elevation it will be 1 dash, 2 dash as well as 12 dash, 3 dash and 11 dash, 4 dash and 10 dash. It will be 5 dash and 9 dash, 6 dash, 8 dash and 7 dash. Whereas in the side view the central one will be 1 dash coinciding with 7 dash. Then you have 2 dash and 6 dash, 3 dash and 5 dash, 4 dash, and then on the other side it will be 8 dash and 12 dash, 9 dash and 11 dash and 10 dash. So far as square is concerned, let us name it as ABCD. So this will be point A dash, we will be naming the square, the points being A dash, B dash, C dash and D dash. In the top view as well as side view, front view, we are required to mark it. So this is going to be the generator for A dash, then this is the generator for B dash, this will be generator for C dash and this will be for D dash. The prism is not to be drawn. And then in the top view, again the generators can be marked, and this generator will be for A dash, we have generator for B dash, then generator for C dash and then that for D dash. So now the naming job is done. What remains is to mark the points. For that we will take help of the side view. It will be the side view and front view together will help us to mark the points. Let us start one by one. Observe that side view is providing us most of the information, like generator 4 dash, generator 4 is cut at 2 points 1 and 2, and we can very well take the path from these 2 points up to generator 4 and mark the points. So 2 points on generator 4, they are marked 1 and 2. Then on generator 3 and 5 we have got another 2 points, so I can draw the projector or the path through these 2 points, and I will be marking the point on generator 5, 2 points, and 2 points on generator 3. Then we have points on generator 2 as well as 6. So as we mark those points, we will be stretching these paths. These are the points on generator 2 and generator 6. So we have marked those points, and then next generators are on the back side. So let us talk about them afterwards, because as we are looking from this direction to see the front view, we will be first considering only these faces which we have already considered, because anything that is on these 2 faces will be completely visible, and that's why we will be first joining these points. But to join these points, I will be looking for exactly at what point this particular B dash will be entering inside the cylinder, and for that we are required to take help of the top view. In the top view you will find that generator B dash is cutting the circle at these 2 points. In top view you will find that generator B dash is cutting the circle at these 2 points, and obviously those are the 2 points where generator B dash should be shown in the front view. So you are required to draw projectors through these 2 points, ultimately giving me the points in the front view as point number 1 on B dash and another point 1 on B dash. That is the bottom point. And similarly for D dash, similarly for point D dash, that is another surface, another generator that we have, D dash is entering the circle or cutting the circle at these 2 points, which is very close generator projector, which we cannot separate out actually. It is one and the same line. So D dash point can be directly considered in the elevation. D dash point can be directly considered in the elevation at the topmost position only. So we get the D dash point over here. And now these curves are to be connected. This is what we want to show. This is the curve of penetration. Which is to be shown in the front view. I am showing the curve which corresponds to the face BC, and then the curve which corresponds to face CD. And so these curves will mark the curves of penetration so far as the front view is concerned. Now for top view, now for the surface or the faces which are behind, namely face AB and face AD, we will have to carry out the same procedure. Observe that generator 1 and 7 is cut at these 2 points, and so we are required to take these 2 points to the front view. So I am just drawing the paths which are to be extended in the front view now. To mark the points on generator 1 and 7. So generator 1 and 7, we get the point, and similarly we get the point on generator 1 and 7. So these 2 points are marked. We proceed further and check whether any other generator is cut. We find that generator 8 and 12 is cut, but again those 2 points are very close to each other, and we will take help of the same generators which are present over here, and then we can mark the points on generator 8 and 12. So on generator 8 we can mark those 2 points. They belong to actually generator A only, and similarly over here 8 and 12. Once this is done, then we will be joining them again by a smooth curve. Like this, and same thing will be done on the other side. This is how it will appear, and remember that there will be some edge which will be seen, which is getting generated. As this is a square hole, that will be the edge of that square. The prism has already been removed. Similarly, there will be a dotted line present over here. Corresponding to the sides of the square, but only 3 sides are there inside the cylinder. The 4th side is outside. And now you are required to complete the darkening of the portion of the solid which is still present. This is how the front view will be completed. Of course, the curves should be smooth. We should be using French curve for this purpose. It is always difficult to draw a curve which is a reverse type of curve. And then proceed to the top view. You are simply required to show the hidden details over here, which are respectively generator A, which is that particular edge is present inside the cylinder because it is a square hole. Then generator D, it has to be shown, and then generator B also is required to be shown as the dotted line. So that will complete our top view, and then the overall solution will appear like this. Dimensioning in this case will be simply related to the diameter of the circle and side of the square, as well as the distance between the axis of the cylinder and that of square hole. No other dimensioning is required. Here the square prism is not to be shown, and the problem will be completed. Make a rough sketch of what this particular object will look like. It is a cylinder. So let us have a look at the sketch for the object. It is a cylinder, and we are going to pass a square prism through it, and when that square prism, a square prism like this, is to be passed through the cylinder, and when it passes, it will be having a portion going like this. It is on the curved surface, goes like this, a portion which goes like this, and is like this because these are the generators, and here is the curve. This is what the back surface will be, and this is how it will appear once you cut it. It is a cylinder which has been cut through. You can also imagine that if this square hole would have been cutting the center, then it would have appeared as this way. This is easy to imagine. This is how it will be seen when it is cut. This is actually the section of the cutting planes, sections of the cylinder through the cutting planes, which are like the one I am showing over here. This is one section, so this portion is removed. There could be another section which is ellipse, and so that part of ellipse will be over here. This is going to be another section which is again the section plane which will form the ellipse or the parabola, and these are the sections which are forming the actual shape which we are getting as the curves of penetration. The square prism, it would have been present. The figure will appear like this. Just imagine, this is a cylinder, and we have a square prism penetrating it. So as it moves towards the circular portion, you will find that there will be a curve over here. There will be a curve which will be generated over here. This is how it is going to penetrate, because the surface is a curved one. So it is present fully till some point, then there will be a curve. And these are the curves of penetration which, after removal of the square prism, will stay with the object. These curves are very difficult to imagine because it will all depend on the position as well as the dimensions. If it would have been a triangular prism penetrating the cylinder, the picture would have been slightly different. Because if it is a triangular prism, say like this, which is penetrating the cylinder, then the one generator will cut here, whereas other generator will be present till some point, and it will be a curve like this. This is how it will be seen. And of course, if the lower portion is visible, there will be a curve which will go like this. It is even easier when we are considering the object to be cutting it perpendicular. The axes are perpendicular. If the axis is making some angle, then it will be even more complicated than the one which we are considering right now. So we can think of another object where the axis is cutting it in an inclined manner. Say a cylinder which is cut by another cylinder, say, which is penetrating it in this manner. Not axes are not perpendicular, it is penetrated in this manner. If this is the situation, then the curves of penetration will be even more interesting, because this is also a cylinder, so it will go smoothly up to a point, and then there will be a curved portion which will be going through. This will be like this, and there will be a curved portion like this, and this cylinder, this generator is behind. This is how it might appear. So it is coming out, there will be straight line type of thing. And if this cylinder is removed, then the object will appear like this. There would have been some shape on the surface of that cylinder. There would have been some shape on the surface of that cylinder, and will be seen in this manner. And the cylinder would have been going through this. A typical case, and these are the cases which we are yet to study in the penetration type of problems. So this sketching is interesting, but may not be every time easy for every student to imagine. The next problem in this category will be dealing with penetration of cone by some other object. Let us consider the case where the cone is penetrated by a triangular prism. Say a cone of base diameter 70. A cone of base diameter 70 is penetrated by a horizontal triangular prism. A horizontal triangular prism of side 50 millimeters. Let us take it as 40 millimeters. Such that one face of the triangular prism. One face of the triangular prism is parallel to VP and is nearer to the observer. Is parallel to VP and is nearer to the observer. The height of the cone, is 90 millimeters. Is 90 millimeters, and the axis of the triangular prism, is at a distance of 30 millimeters, from the base of the cone. Draw three views with the curves of penetration. So in this case, we will be again starting with the top view, and the circle in the top view should be divided into 12 parts, but this time we will be joining them because it is a cone problem. We are even required to join each point of the base to the vertex. So in short, when you divide it, you are required to show all those diameters. Which are making 30 degrees angle with each other, so that it will appear in the form of 12 points of the base which are connected to the vertex, and we will take those points up to the base of the cone, that is XY line, in front view, and the same 12 points should be taken to the side view also. So we are required to take these 12 points to the side view. And then to complete the side view, we are required to rotate them with the point of intersection of the vertical line with XY. So the same considerations again and again. To obtain the side view, there is no different procedure as such. There is a reference of each point that we are marking in the top view with the corresponding point in the side view. So perform the rotation of all the 12 points of the base. And so you get the reference for the side view, where you can always show the axis of the cone distinctly. Height you can mark from the front view, and these points should be connected to the vertex one by one. All of them should be connected to the vertex. These are the 12 generators of the cone. Which we are marking in the side view, and of course we are required to mark them even in the front view also. So we complete the side view, and in the front view join those 12 points of the base to the vertex. and so the three views of the cone will be now complete. We can go for the naming as usual, starting from the leftmost corner. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Similarly, the points in the front view, 1 dash, this will be 2 dash and 12 dash, 3 dash and 11 dash, 4 dash and 10 dash, this will be 5 dash, 9 dash, 6 dash, 8 dash and 7 dash. And in the side view it will be, center one will be 1 dash as well as 7 dash, then this will be 2 dash and 6 dash, 3 dash and 5 dash, this is 4 dash, and then this is going to be 8 dash and 12 dash, 9 dash and 11 dash, and the leftmost is 10 dash. The triangular prism is having its axis at a distance of 30 millimeters from the base, coinciding with the axis of, or it is perpendicular to the axis of the cone, and we are required to draw that triangle separately and then it should be transferred. So a triangle of side 40 is to be drawn. A triangle of side 40 is to be drawn. That construction should be there, and then mark the center of that triangle, that is the axis of the triangular prism. So first of all, complete the triangle. Of side 40 millimeters. Take the midpoint of two of the sides and join it to the opposite corner of that triangle. So that we get the radius of the circumscribing circle. And then draw that circle in the side view. Once you draw this circle, then we are going to look in this direction. Side view will be seen in this direction, so that we can obtain the view called as the front view, and it is given that one plane of that triangular prism is parallel to VP. So this is vertical plane in that case, parallel to VP and towards the observer. So it should be like over here. So the vertex goes on the other side. So you will be simply drawing a horizontal line to get the vertex of that triangle, and then take the side equal to 40 millimeters and mark the two points which will be forming the triangle. Make sure that they lie on the same vertical line, and they will. So this is how that triangular prism will be seen in the side view. In this case, fortunately, one corner lies exactly on the end generator. We can darken the side view that is the end generators are made dark. That completes our side view of the problem. And then from the side view we will name the corners of that triangular prism as A, B and C, and those points should be taken to the top view. So we will have to simply draw the projectors through them, and then through rotation we are required to take all these points to the top view. We are required to take all these points to the top view, and so there are 2 points which are to be taken. One is point A, transferred to the top view, and the other corresponds to B as well as C, taken to the top view. May not help us a lot in this case, this is not a cylinder, but still those generators are taken. And similarly these points are to be transferred to the front view also. Let us assume that the length of that triangular prism is projected out of the cone by 10 millimeters, so that I can draw the face, triangular face, which appears as a line in the front view, and the same thing can be marked in the top view. It is just coming out of the cone base diameter by 10 millimeters. And now is the difficult time. You are required to again go back to the side view. You will have to go again to the side view, and then pass the generators through all the 3 corners of the triangle. Out of that, A is already on the generator. There is no generator passing through point C, so you will have to pass that generator. There is no generator passing through point B, so pass that generator also. And now these 2 points which we get, they should also be transferred to the top view. These 2 points should be also transferred to the top view, that is through rotation. 1 and then the second. Once we get those points in the top view, once we have transferred them to the top view, then we are required to first of all mark those points on the circle. So I am drawing the horizontal line and marking those points on the circle, and then I am supposed to join them to the vertex, because those are the generators of the cone. So these points also should be connected to the vertex of the cone in top view as well as even in the front view. So in front view also we are supposed to mark these generators, which can be straight away taken up from here. So the points are to be transferred to the base, and then they should be connected to the vertex So we get the generators on which point B and C will lie. A is already on one of the generator of the cone, so that construction is not required. Of course, you can name those generators as generator B as well as C. So here also it is generator B and C, and in elevation that will be generator B dash, then the other one will be C dash. Here you have C dash and B dash. So these generators can be now marked. And now let us proceed to mark the points. First of all, I am going to talk of face BC. So point C can be marked directly on generator C dash. Point C can be marked on generator C dash, and point B can be marked on generator B dash, which is not a very complicated thing as such. So these are the 2 points at which the vertical face is entering inside the cone. So you can darken that much part. So these points are marked in the front view. Then check whether any other generator is cut. Any other generator is cut by the face BC, and we find that generator 26, generator number 2 and generator number 6 is cut, and then that point of intersection can be transferred, and you can mark the point on generator number 2 as well as generator number 6. So the point on generator number 2 is this point, and point on generator number 6 is this point. So these 2 points can be marked, and then we can join these 3 points by a smooth curve. It should be connected by a curve, because cone is a curved surface. So these 2 get connected by the cone, by the curved surface as such. Then let us proceed further. Face AC that we have, face AC is cut by, first of all, generator 2 and 6 once again, generator 2 and 6 once again, and so that point can be transferred onto generator 2 as well as generator 6. So generator 2 one point and generator 6 another point. Then generator 1 and 7 is cut at this point. So generator number 1 and 7. So you can mark the points. Then we have generator 8 and 12 which is cut. So we can transfer the points on generator number 8, generator number 8 and generator number 12. So the point can be marked. Then even generator 9 and 11 is cut. So generator number 9 and generator number 11, those can be marked, and point on generator 10, that is A. So this is the shape that we get on face AC, which is behind as we are looking from this direction. As we are going to look from the right hand side direction to obtain the front view, this face will not be visible and so we have taken the intersections of face AC. So all the points which we get over there in the front view, those should be connected by a smooth curve, but that will be a hidden curve which will not be seen. So this should be drawn as an hidden curve, which is actually on the back surface of that triangular prism. So this is one surface that we have considered, and that's why here it is one-to-one correspondence that should be taken into account, otherwise it is very much problematic as such. Then we again go back to intersection of surface AB, and then point on generator 9 and 11 is to be transferred. So point on generator number 9 and 11. So this is generator number 9, the point on it. Generator number 9. We have a point here and a point over here. Then generator number 8 and 12. So it is the same line. So it is generator number 8. So we get a point over here. So these are the 2 points. Then generator number 1 and 7. So we get these 2 points. And then point B. So here the another hidden curve will come into picture. Which can be drawn in this manner, and then the portion of the generator which is going inside, that should be shown by the dotted line. Even the other generator should be shown as dotted, and the generator which is behind also should be shown by the dotted line. So these are the generators of the triangular prism which are shown. Then what remains is the generators of the triangular prism, and you will find that generator 1 and 7 are present up to this level and from this level onwards. So we will be drawing them. May not be visible fully from the front, so only this much portion is visible. Rest is going behind the triangular prism, so dotted. In between it is not present. Afterwards it is partially invisible behind, and the rest of the part is visible. Same thing will happen for generator number 1. It will be visible up to a limit, then it will be dotted, then it will be dotted here also, and then will be a full line. That will complete the front view of this particular problem. One of the very complicated front views as such. So many points are there. The curves which will be hidden. Some full curve is also there, which is on face AB or face BC. So this was that full curve which was present. Okay. And then all these points should be transferred to the top view, which is one of the very critical part into it. And that job can also be done because we are required to show the curves of penetration in the top view also. In the previous problem it was being a cylinder or prism. We did not have any such curve, but now we will have to transfer these points. So one by one you are required to transfer them, or you can take them from the side view. Like we have point 1, point A, which lies on generator 10. This can be marked directly. Then if I am considering the top surface, I have a point on generator 8 and 12 and it is on this line. It is a point on generator 9 and 11, so it can be marked 9 and 11. Then generator 8 and 12 is cut at this point. This should be transferred using compass. So this is a point on generator 8 and 12. So I am transferring it and should be marked on generator 8 and 12. Then point on generator 1 and 7 should be taken from the front view itself. Should be taken from the front view itself. So point on 7 and point on 1 is taken directly. And then we have point on generator 2 and 6. So even that point is to be taken down. Should be rotated to get the position in the top view. And then in the top view you will get those 2 points on generator 2 and generator 6. So you got those 2 points. And then finally the point on generator C, which will be the topmost point. In this case it is generator C coinciding with generator B. So this is the point which will lie on generator through C. So you get these 2 points, and this is the curve which is to be drawn fully to complete the top view. The curve which appears, say, in this manner, which is actually a part of ellipse. And then you will find that generator 7, this is how it should be shown, remaining portion is inside, whereas this generator is shown fully. But that is so far as the curve which is present on the surface AC. Same is the case with surface AB. You are required to transfer the points. So generator 9 and 11 is cut at this point, so we can take the point down, and that should be rotated. And should be marked on 9 and 11. Then you have generators 6 and 8 cut at a point. A generator 12 and 8 are cut at a particular point. Even that point should be rotated back to get the points on generator 8 and 12. So you will get a point on generator 12 and point on generator 8. Then points on generator 1 and 7 can be marked directly through the front view. So point on generator 7 and point on generator 1 can be directly marked. And then you have point on generator 2 which is directly present, a point on generator B, I suppose, point on generator B which is directly present, and this curve which is present but is not visible from the top also should be drawn. and then the portion of the cone which is going below the prism, only that part of the circle should be made dotted because it will not be visible from top, and so this will be the portion that should be made dotted. And we complete the top view also. So even if we have some larger dimensions, the problem turns out to be pretty complicated as we start with showing each and every detail of that particular object. So many projectors going through so many points becomes a very complicated thing. One who can practice for such a problem can surely get any other problem of the penetration. So it is curves of penetration or interpenetration of solids, which is the name of this particular topic, becomes more and more difficult as we proceed with more complicated objects. This is the solution. We have front view with penetration curves, we have top view with curves of penetration, and the side